This final lesson we're going to look at, we're going to be dealing with square roots, or radicals if you would. We're going to confine ourselves to talking about square roots later on. You might talk about cube roots, fourth roots, fifth roots, and so on. But we're going to confine our conversation here today to square roots. And what we want to end up doing is adding them together, subtracting them, and multiplying them. A little bit later on we'll talk about dividing them, because there's some real problems with dividing radicals. And we need to set that up a little more. So we're just going to do addition, subtraction, multiplication. And the first thing we need to review, and we've already done this a little bit earlier in the chapter, is called simplifying a radical. We want to make it as simple as we can. For instance, if we look at the square root of 12, that can be written a whole lot more simple than the square root of 12. By asking yourself, which one of the perfect squares will divide into 12? And I can see on your faces already you're asking, what the heck are perfect squares? Okay, if I square 1, what do I get? That means multiply 1 times 1. I get 1. If I square 2, what do I get? 4, exactly. So the perfect squares the first one is 1, and then 4, and then, there we go, we know what they are, and let's do a few. 16, 25, there we go. And I'll just do a dot dot there because I can tell right now, you know what those are. That's wonderful. So now, we go to this list of perfect squares and we ask ourselves, what's the biggest one over there that will divide into 12? And it's 4. So we write 12 as the square root of 4 times the square root of 3. And now what is the square root of 4? 2. So this becomes 2 multiplied by the square root of 3, and that's a simplification for the square root of 12. Let's do another one with numbers, just quickly here. Square root of 27. Out of this list, which is the largest number of the perfect squares that will divide into 27? 9, exactly. Very good. So we write it as the square root of 9 times the square root of 3. And the square root of 9 just happens to be 3. So the simplest form of this is 3 times the square root of 3. Now this gets just a little bit hairy if I throw letters in there as well. And I would like to do that. I'll do just letters for the moment. What's the largest square that'll divide into x cubed? Now that might be a hard question to answer.
X squared.
There you go. Wonderful. X squared is. So we write this as the square root of x squared times the square root of x. And the square root of x squared is x. Very good. Very good. You said that hesitantly, and that's exactly the right answer. So we have x times the square root of x. Let's try one more here. Let's go x to the 7th as an example. We'll see if you understand this idea of the largest square that will divide into that. Okay, we're kind of looking at each other. The largest square that will divide in there is x to the 6th. X to the 6th. If it's going to be a square, it has to have an even exponent. X squared is a perfect square. X to the 4th is, x to the 6th, x to the, help me, 8th, x to the 10th, and so on. Has to have an even exponent. So we can write this as the square root of x to the 6th times the square root of x. And how about square root of x to the 6th? What is that?
X to the 3rd.
Third, there you go. You had the right idea, it's x to the 3rd. Perfect. Perfect. Now, let's just do one real quickly with both a number and a letter and see what happens. See if we can really do this. 72x to the 5th. And we want the square root of that. Okay, so let's look at the number first. Okay. What's the largest square, perfect square, that'll divide into 72?
9. No.
9 will. Is that the largest, though? I'll give you a hint.
Oh, 36.
36 will, yes. Those kind of hints are fun, aren't they? Sure. So, and sometimes we need to have a hint here. So I'll write that as the square root of 36 times the square root of 2. All right? 36 times 2 is 72, right? Now how about this one? It's the largest square in x to the 5th.
X to the 4th.
Good for you. So square root of x to the 4th times the square root of x. So now the square root of 36 is 6. And this is a little out of order, but we need to be able to do this, I think. This is the next one that's going to come out even, and that's x squared. I'm going to write that next. And then these two can't be simplified any further, so we're just going to write the square root of 2x like that. So that's our simplification. Now, although that looks pretty nasty, it's more simple than the first case. It's more simple than the first case. So what we've done so far is just simplify them. Now we'd like to be able to take some of these square roots and add them or subtract them or multiply them. So I want to look at a couple of examples of that with you. And you're doing a very nice job here, so just keep it up. We're almost done with this lesson. And we can go home. I'll steal an example that was on the page here. 4 square roots of 12 minus 2 square roots of 18 minus 2 square roots of 27 plus the square root of 50. Now, do any of those look alike right now? No, they don't at all. And if we're going to add and subtract, we can only add and subtract things that are alike. So what we're going to do first is simplify some of these radicals. And the first one we'll simplify is the square root of 12. And we just did that one, so I'm going to do that one a little quickly. That will end up as the square root of 4 times the square root of 3, which eventually becomes 4 times 2, which is 8 square roots of 3. Now let's just check that one first. Is there a problem with that or not? 8 square roots of 3. I kind of did 3 lines here, and that's not real good mathematics, but stick with me if you can here. Square root of 18. 9 will divide in there, so I think we have 2 square roots of 9 times the square root of 2, which becomes minus 2 times 3 times the square root of 2, or 6 square roots of 2. The next one, we've already dealt with that one, so I'll do that again fairly quickly. 2 square root of 9 times the square root of 3, which is 6 square roots of 3. And the last one we haven't dealt with, what's the biggest perfect square that will divide into 50?
25.
25. Good, good, good. So we've got the square root of 25 times the square root of 2, which is 5 square roots of 2. Now, what we've done is effectively simplified each one of those statements. Now, do we have anything that's alike? Okay, I see some heads nodding, and I agree, we have some things that look alike. This one here would be called a square root of 3. That's the name of this term. How many are there? There's 8 of them. Here we have another square root of 3, and technically there's negative 6 of those. So 8 of them here, negative 6 of them there, 2 of them all together, and it's 2 square roots of 3. Got to keep that name. All right, here we have a square root of 2, and there are negative 6 of them. We have a square root of 2, and there are 5 of them. Totally, we have negative 1. We don't normally write that, but I'll say 1. Negative 1 square root of 2. So the best answer for that particular problem is 2 square roots of 3. Take away the square root of 2. Well, that's fairly complicated. You did a nice job on that one. It's just a matter of getting things simplified, and then you can see what's alike here, and then combine just the things that are alike when you're adding and subtracting. If you multiply, that's immaterial. Likeness doesn't make any difference. If you think back to one of the other lessons we did, we multiplied 2 times 3 feet. Well, 3 is feet, and 2 wasn't feet. We multiplied that, got 6 feet. So things don't have to be alike to multiply, but they do have to be alike to add and subtract. I guess there are 2 more examples here that would be pertinent that we probably should take a look at. And then you should have a fairly decent understanding of operations with these things. And this one is 4 square roots of 5 multiplied by the quantity. 6 square roots of 5 minus the square root of 10 plus 4 square roots of 7. Now, anytime you have a number multiplied by a quantity, and it's been a while ago since you've heard this property. Anybody know what that property is called? That tells you how to multiply a quantity or a number times a quantity? It's called the distributive property, and it's just like my taking your tests on Friday and giving them back to you. I'm distributing 1 to you, 1 to you, 1 to you, and so on. And what that distributive property is saying is, this number needs to be multiplied by each of those in here. We have to distribute this number over that whole class. So, these 2 multiplied will give me 24 square roots of 25. Any question on that? 4 times 6, 24, square root of 5 times the square root of 5, square root of 25. Now you might be saying to yourself, well, I already know what that is. Well, that's good. We'll get to that. But for right now, let's just do that. Now we're going to take it times the second one, and I think we end up with negative 4 square roots of 50. And then finally, plus 16 square roots of 35. And now, if we can simplify, we certainly should. And this becomes 5. And 5 times 24, I hope is 120. My batteries are a little low, but I think that's what it is. Square root of 50 doesn't come out even. That's close to 7, but that's not what it is. But we can simplify that. This is 25 times 2. So we have negative 4 times the square root of 25 times the square root of 2. And we'll come back and take care of that square root of 25 in a minute. And this square root of 35, I don't know where that came from. That can't be simplified, and that's just an ugly looking thing. So we need to leave that alone. It's one of those we just can't do anything with. An unruly square root. So now we should go back and simplify this as best we can. 120 subtract Now these two multiply together, this is really 5 of course, so we have 20 square roots of 2, and then we have 16 square roots of 35. Now it says add and subtract, but they are as simple as they can be, and there's nothing alike. So that's the best we can do. One more example. Hang in there, gang, we're almost there. And this is going to go back to the FOIL method that we talked about a while ago. 4 square roots of 3 plus the square root of 2 multiplied by 2 square roots of 3 minus 5 square roots of 2. Alright, so this is just like x plus 6 and x minus 7 as an example. Those are two binomials. So the FOIL method, we need to multiply this times the first one over there. And it looks to me like 8 square roots of 9, and you can giggle about that, but we'll leave that for a moment. 8 square roots of 9. Now we need to do outside and inside. Outside would be 20, actually negative, 20 square roots of 6. I would be plus 2 square roots of 6. These two, I. And finally, L would be negative 5 square roots of 4. And again, you should have a smile on your face for some of these, because we know square root of 9, we know square root of 4, and by golly, these are both square roots of 6, so we can put those together. We're cruising here. So this will be 8 times 3, or 24. These two, as I said, are alike, so that should be negative 18 of those square roots of 6s. And finally, over here we have negative 10. Oh, we're not done yet. We have this, and that can be combined. So I think we end up with, finally, 14, take away 18 square roots of 6.